Hello, this is Mrs. Hyman. Find the value of the discriminant for each quadratic equation. Then describe the number and type of roots for the equation. Well, first we're going to write down what the discriminant is, and that is we have b squared minus 4 times a times c. And basically we have three different situations here. We can have when that is less than 0, which means that we have two complex roots. We can have when that is equal to 0, and that means we have one real solution or one real root. Or we can have when that is greater than 0. And that means that we have two real solutions. And in fact, we can take that further. If this is not only greater than 0, but it's a perfect square, then we know that we have integer values or rational roots. So now we're going to use this discriminant, b squared minus 4ac. We're going to evaluate that first, and then we'll determine what category we have here. In our first equation, 15x plus 10x squared minus 25 equals 0. We have to be careful because it's not in standard form, so our a value is 10. It's that coefficient of x squared. The b value is 15, and the c is negative 25. So now we're going to take these values and put them into our discriminant. So b squared, so that's 15 squared, minus 4, now times a, which is 10, times c, which is negative 25. Well, 15 squared is 225. And then we have 4 times 10 times negative 25, and that would be negative 1,000. So subtracting a negative makes that plus 1,000. And if we add those together, we get 1,225. So we see so far that it is greater than 0. So we know that we do have two real roots. And if we look further to see, do we have a perfect square? And yes, we do, because 1,225 is equal to 35 squared. So those real roots are also going to be rational. Our second equation, 6x squared plus 2x plus 5 equals 0. Well, again, we're going to use the discriminant, and this time a is 6, b is equal to 2, and c is equal to 5. So b squared, that would be 2 squared, minus 4 times a, which is 6, times c, which is 5. And now we'll simplify. 2 squared is 4, and 4 times 6 times 5, 120. 4 minus 120 equals negative 116. So this time we have our discriminant less than 0, which means that we have two complex number roots.